now that we understand that force is a vector, we can then start doing operations on that vector. So let's say we have our can again, but instead of having a mass, we're going to simplify and say our can has a weight equal to 10 pounds. And that is obviously acting down, which means the table has to have a weight of 10 pounds acting up. Well, let's say that I double the size of the can so that I double its weight. So we're going to say we have 10 pounds times 2. Well, then we'd have 20 pounds. And our reaction force would now be 20 pounds. So the magnitude changes. If I double 10 pounds, I have 20 pounds. What does not change is the direction. Since this is a weight acting down, this weight still acts down. What we just did to this force vector of 10 pounds is multiply it by a scalar. And when you multiply by a scalar, it's very simple. The magnitude changes. But the direction stays the same. So multiplying by scalar scales up and down the magnitude, but the direction does not change. To contrast this, we have addition. So let's again say the can has a weight equal to 10 pounds. But let's say I come in here and I use my finger and I push the can sideways with a force of 5 pounds. So we have 10 pounds acting down, 5 pounds acting to the right, but the can isn't moving, so we're going to say that it is in equilibrium, or static equilibrium, which means that the table is acting up with a force of 10 pounds, and to the left with a force of 5 pounds. Now, if we wanted to know what the total resultant force of the table acting on the can is, we can apply a coordinate system. Let's say that y is up, and we'll say that x is going to the left because we have a force acting up and to the left, and this allows us to work with only positive quantities. On this, we have 5 pounds, and we have 10 pounds. If I want to know what the resultant force is, all I need to do is Pythagorean theorem, which says a squared plus b squared equals c squared. To find the resultant, I'm just going to say the resultant is equal to the square root of a squared plus b squared, which is going to be the square root of 5 squared plus 10 squared. And this will give me a resultant force equal to 11.8 pounds. If I want to find out what angle this force is occurring at, I can use the tangent. So the tangent of theta is equal to the opposite over adjacent, or the rise over the run, however you want to put it. In this case, it's going to equal 10 divided by 5. And if I do the inverse tangent, I'll find that theta is equal to 63 degrees. So the resultant force of the table acting on the can is 11.8 pounds acting at 63 degrees from our positive x-axis. Now, when we did this calculation, the 5 plus 10, you can see that we did one calculation for the resultant force, which gives us our magnitude. And we had to do another calculation for our angle, which gave us our direction. Now, since we can take two forces and put them together into a resultant force and an angle, we can always break any force into two forces. So let's say here we have a 200-pound force acting at 38 degrees from the x-axis. We can take this force apart into two components acting directly on the x and in the y. If I want to find the force in the x direction, I can simply find it by doing 200, which is the magnitude of the force, times the cosine of 38, and that is equal to 157.6 pounds. I can find the force in the y direction by saying 200 sine of 38 degrees, which is 123.2 pounds. What we've done here is taken a force acting at an angle and broken it down into its x and y components. These x and y components are in our 2D coordinate system, and this is a two-dimensional rectangular coordinate system. So these forces in the x and y can be considered to be the x and y rectangular components of this 200-pound force. Again, if we have two components or two rectangular coordinates, 100 pounds, 80 pounds, we can combine them into a resultant using our Pythagorean theorem. So we can say R equals the square root of 100 squared plus 80 squared, giving us a resultant force of 128.16 pounds. And we can find our angle by saying theta is equal to the inverse tangent of 100 over 80, which is 51.3 degrees. So our resultant force is acting in this direction. It has a magnitude of 128.16 pounds and an angle of 51.3 degrees. And one main point that I want you to take from this is the fact that we could have multiple forces. We could have 10 forces all acting at different angles. The easiest way to add forces is if you turn it into its rectangular components, which would be the 100 and the 80 pounds here. Add all those rectangular components together because they're all acting in the same direction, and then go back and find their resultant force. This is the way I would have you deal with every force that you possibly can.